Hello and welcome to Project152, your weekly specialist exam prep. Now every week we go through past questions from the QCAA. If you stick with us from now until the end of term 3, you'll have done every single question the QCAA has ever released. This week is week 18 and we're going to go through the solutions. Let's go! So we have a vector equation here describing the displacement of a particle, and we're trying to determine the corresponding Cartesian equation. So this particle is moving through space and its x-coordinate is given here, t plus 2. So I'll write that down. The x-coordinate is t plus 2 and the y-coordinate is given right here, y equals t squared. And the goal here is to get these equations into one Cartesian equation. Now we need to make y equals something. So we'll leave this as it is, and we just need to replace the t with this equation somehow. So rearranging this equation, we get t is equal to x minus 2, and we can sub x minus 2 into this equation. Y is equal to x minus 2 squared. Now, this kind of looks close, but it's not it. All right, maybe we need to expand this. So y equals x minus 2 times x minus 2, which is x squared, minus 2x, so that's minus 4x, and minus 2 times minus 2 is positive 4. So our answer is y equals x squared minus 4x plus 4. Can I see that? Yes, it's option C. Celebrate. Next question. So a Leslie matrices question here, and we don't have to do any calculation. We just need to take this information and come up with some more Leslie matrix here. So maybe I'll just recreate my Leslie matrix here, and we'll see what we end up with. Now look on the first row, female population. This information here, 94, 82, 37, 6, that doesn't go in our Leslie matrix. That goes in our population matrix. So this first row we should ignore. It's some kind of distraction. All right, our breeding rate there, this goes along here. So 0, 1.3, 0.9, and 0.2. And then the last piece of information, the survival rate, diagonally starting here, right here. So 0.6, all of these are 0, and then that's 0, and then this one here is going to be our next one, 0.8, and then a bunch of zeros, and then 2 zeros, and then our last one, 0.4, and then a 0. And then we just need to look at these 4 options and see if we've got an answer. And yes, our answer is D. Celebrate. Next question. So a tricky little question here, and there's 2 pieces that we need to consider. So we're coming up with subsets, complex numbers, and it says the shaded region defined as this, and then intersection this. So we need to consider this, and that's what intersection means, and this. Now, I actually think the second part's the easier one, and I'm going to deal with that first. So what does that say? All right, it says the complex numbers where the real component of them is less than 1. Okay, so see these dotted lines in all of our diagrams? That's supposed to be the number 1 there, right? And so we want all of the complex numbers where the real component is less than 1. So 0, -1, -2, -3. So that means that my options are either this one, because you can see here's 1, and the shaded region is all less than 1. And it also leaves me this one. You can see here's 1 along here, and the shaded region is less than. Here is 1 and the shaded region is greater than 1. And here is 1 and the shaded region is greater than 1. So let's cross out A and C as our options. Now I am going to do this part here the long way, but I will also talk to you about the shortcut at the very end. All right, so how do we deal with this? Well, we can turn it into the equation of a circle by substituting this z for x plus yi. So now that I'm letting z equal x plus yi, we can put x plus yi in there, in that z. So it's going to be the magnitude of x plus yi, and then the next bit, plus 2 minus I, is, what have we got? Is less than or equal to 5. Is less than or equal to 5. I'm just going to substitute, this is just a multiple choice question, so I'm just going to substitute this for the equal sign, just because it makes the equations just a little bit easier to work with, and then we'll worry about the less than in a second. Alright, so don't worry about this, we'll deal with it later. So we're finding the magnitude of this. Now we need to have our real components together. So our real components are x and 2, and our imaginary components are y minus 1 I. So I've just factorized this yi and this minus I to be y minus 1 I. We're finding the magnitude of that equal to 5. Alright, so the magnitude is going to be equal to that, the square root of this squared, x plus 2 squared, plus this squared, y minus 1 squared, equal to 5. And now I just square both sides, so I have x plus 2 squared plus y minus 1 squared. Squaring both sides, this becomes 25. Okay, now I have the equation of a circle, and you should know that the equation of a circle, the center of this circle is going to be equal to -2, so the sign swaps, -2, and +1. Now, can we see a circle here between these two options where the center is -2 and +1? So -2, +1. Looks like that one. This one, its center is like probably +2, -1, so the reverse. So our answer here is B. Now, before we celebrate, I just want to mention this style of thing happens so regularly that you actually shouldn't have to go through all of this. You should look at this and see, wait a minute, magnitude signs, we've got this thing here, it's a circle. The center of that circle is going to be the negative of this real bit here, so -2, and the positive of this, so swap the signs there, and you should be able to jump straight from here to knowing straight away that the center is this. We also know that the radius is going to be the square of 5, so in this case 25. So you can kind of look at that, sort of jump over a few steps and get straight down to here because it happens so often that you know exactly what's going to happen next. Celebrate. All right, next one. I did promise that I was going to think about that less than thing again before I left. It didn't really matter because we didn't need to consider that, but less than or equal to, the shading is on the inside of the circle because it's less than. If it was greater than, it would be outside of that circle. So just something to keep in mind. Double celebrate. Alright, so a couple of neat little integrals here. Now it's a part A, it's part B, so let's get rid of part A. Focus on part A. So we've got the integral between 1 and 0 of 1 on 1 plus x squared. And this kind of pattern should ring alarm bells. You should look at it and think, hey, I think I've seen that before on my formula sheet. And you should be thinking of these things here. Now, the first one has like a square root on the bottom. This one doesn't. The second one has a square root on the bottom. This one doesn't. So this one looks like a likely candidate. Now, you might be looking at it saying like, oh, there's an a on the top and there's an a squared on the bottom. That's fine because 1 and 1, this is a, 1, and 1 squared is also 1. So that fits this formula perfectly. So let's write it all out. We're finding the integral between 1 and 0 of this. And I think that we can probably just do it straight away. We know that the answer is inverse tan, and then on the top will be the x. You can see this is x squared here, this is x squared here. So on the top will be x, and on the bottom will be a, 1. Now, x over 1 is just x. So that means this is just going to be inverse tan x. All right, inverse tan x, done. Now, we don't need the plus c because we're doing a definite integral. And we're doing a definite integral between 1 and 0. So now we just need to sub in 1 and 0, inverse tan of 1 minus inverse tan 0, and now we just need to solve these two values here. So inverse tan 1, you might not be used to playing with this too much, but just have a little think about it. Tan theta equals 1, theta equals inverse tan 1. All right, so that's what we're driving at here, and you should be used to solving equations like this. The angle here is pi on 4. So pi on 4. And then tan 0, that's the same idea. Tan theta equals 0. So theta equals inverse tan 0. And you should know that this has an answer of 0. So we have pi on 4 minus 0. Our answer here is pi on 4. 2 marks for it. So we'll do a little mini celebration for this one, but that was just part A. So we've got to move on to part B. All right, so clean all that up. Here's part B. There's part B right here. Let's move that up, get rid of part A, focus on this one. And so you might be thinking, okay, it's an integral. I should go look at my formula sheet, look at the integration section. There's like a whole bunch of integration things. But what's missing from here is this sine squared. I can't see a sine squared here anywhere. That feels like a problem. But then you remember, hey, there's another section of my formula sheet full of trig identities. And one in particular that's going to be useful to us is this one here, the double angle identities. You can see a sine squared sitting there. In particular, let's write it out. Cos 2a equals 1 minus 2 sine squared a. So I've just written it out here. So I'm getting it from that second formula, cos 2a equals, and then I'm using that second line. Okay, not that useful to me though, because at the moment you can see I have this like 2 sine squared a. So I just need to rearrange this a little bit. I might move all of this to this side to make it 2 sine squared a. And then it's going to be 1 minus cos 2a. Now this is a useful formula because now I can substitute this 2 sine squared x for 1 minus cos 2x. So let's write that. We're going the integral between pi on 4 and 0 of not 2 sine squared x, but 1 minus cos 2x with respect to x. And now I just need to integrate that. Now integrating that is methods work. I don't need to show you how to integrate cos 2x. Okay, so the 1 becomes x and the negative cos 2x becomes negative 1/2 sine 2x. And we're still integrating between our terminals pi on 4 and 0. So let's put pi on 4 in here and put 0 in here and here, subtract them from each other. Let's do that. Now this is the first part of it. I've subbed pi on 4 in for x and I've subbed pi on 4 in for x. Now I can simplify that a little bit. 2 pi on 4 is going to be the same as pi on 2. All right, we'll deal with that in a second. And then we sub 0 in here somewhere. Now I've written sine 2 times 0, which is of course silly. That's just sine 0. But of course, even bothering to do that's too much because this is 0 and sine 0 is 0. So we're subtracting 0 from whatever this happens to be. So now we just need to figure out whatever this is. All right, so we have a pi on 4 here. And then we've got our minus 1/2 and then sine pi on 2. Sine pi on 2 is equal to 1. So finishing this off now, we have pi on 4 minus 1/2 times 1 is minus 1/2. Minus 1/2. Now that looks like not a great answer, but that is the answer. Pi on 4 minus 1/2. You'll see this happen in both methods and specialist. Your tech-free answer often isn't just a single number or a single fraction. It's a number that includes pi and then some other rational number of some sort. So answer, pi on 4 minus 1/2. Celebrate. Last question. So a fun little question here. A curve is defined by the parametric equations this and this. Given dy dx can be expressed in this weird form here, find a and b. So really the question is asking us to find dy dx. Once we have dy dx, we might have to rearrange it to get it into a form that looks a bit like this and then solve for a and b. Okay, how am I going to find dy dx? What's the trick? Let's look at this equation. X equals 2 tan theta. Now that's not an equation in terms of x and y, it's an equation in terms of x and theta. This one here, it's not an equation in terms of y and x, it's an equation in terms of y and theta. So we should be thinking related rates. So we should be able to write this, dy dx equals, and here's how I like to write this, d, the other thing, theta, over dx, times dy d theta, the other thing. So now I just need to find out these things here. Once I've got that, I'm in business. All right, how am I going to find that? The derivative of theta with respect to x, the derivative of y with respect to theta. All right, let's deal with the x one first. X equals 2 tan theta. Well, let's write it up here. X equals 2 tan theta. All right, the derivative of x with respect to theta is equal to whatever the derivative of 2 tan theta is. Now, don't expect you to memorize everything. You've got a formula sheet. The derivative of tan x is equal to sec squared x. So the derivative of 2 tan whatever is equal to 2 sec squared whatever. So 2 sec squared theta in this case. All right, you'll notice that for my equation to work, I don't want dx d theta, I want d theta dx. Right, that's fine. D theta dx is just the reciprocal of this. 1 over 2 sec squared theta. Okay, great. I'll be able to take that and put it in here. So now I just need dy d theta. So let's do that over here. We know that y is equal to 3 sine 2 theta. And that means that the derivative of y with respect to theta is equal to the derivative of that. So the derivative of 3 sine 2 theta is equal to 6 cos 2 theta. Great, now I can take that and put it here. All right, so we're going to put that there, we're going to put that right there. All right, straightforward, that came from here, and this comes from there. And now we can smush them into one fraction, easy. So we're getting really close, even though it might not look like it. Eventually, we need to have dy dx equaling something cos 4 theta plus something cos squared theta. What we don't want is like a sec. But luckily, we know that sec is equal to 1 over cos squared, right? So, actually, let's do a couple of things. 6 and 2 become 3. So this is just 3 cos 2 theta. And so that 2's gone now. And we're just left with a sec squared theta on the bottom. But sec squared theta is the same as 1 over cos squared theta. So we have 3 cos 2 theta over 1 over cos squared theta. If we're dividing by 1 over cos squared theta, that's the same as multiplying by cos squared theta. So all of that to say that this can now move to the top as cos squared theta. So we have 3 cos 2 theta times cos squared theta. Getting closer, right? Let's look at where we're supposed to be getting to again. You can see this theta here and this theta here. The problem is this 2 theta. We should be able to deal with that using some kind of trig identity. All right, here we go, and bam, double angle identities. Now we've got this cos 2a, cos 2 theta, cos 2a. Cos 2a is equal to, right down the bottom there, 2 cos squared a minus 1. 2 cos squared a minus 1. So that means I can replace this thing here, this cos 2 theta, I can replace it with 2 cos squared theta, not A, and then a minus 1. And that is going to get multiplied by cos squared theta. Okay, great. I feel like we're getting real close, because now we should be able to expand all of these brackets. So I might leave the 3 until the end, because at the moment it says 3 times this times this. So leaving the 3 out the front, we have 2 cos squared theta times cos squared theta. That's going to be 2. Cos squared times cos squared is cos to the 4. That's good news, because we know we're looking for a cos to the 4 by the time we finish this. And then negative 1 times cos squared theta is negative cos squared theta. Okay, very close. And now I can expand that 3 into it, and I end up with 6 cos 4 theta minus 3 cos squared theta. Am I done? Am I done? Something cos 4 theta, something cos 4 theta, and then something cos squared theta. Great. I'm finished. Therefore, A is equal to 6 and B is equal to, got to be a bit careful, negative 3. Done. All right, a fun little question there. We've got some related rates. We've got some trig identities. They love to put some of that stuff into this year 12 things. I think it's a fun question. Celebrate. So that was week 18, another week down. Now, if you go to the link in the description, you'll get next week's questions. I'll see you in exactly 7 days, same time for those solutions. It's going to be tech active next week, so make sure you get your calculator out. Super important to practice those calculator skills. Catch you next week.